Okay, this is lesson 8, expanding on exponents. And if you recall from lesson 5, we had an introduction to exponents. You may want to go back and view that again before we carry on with this lesson. Okay, starting at the top of page 20, we have the base number b with an exponent m, and that's multiplied by the same base number b but a different exponent n. And the way you solve this is you add the exponents. So let's put some numbers in here and make more sense of this. To be able to add the exponents, so these base numbers have to be the same. So let's use 2 to the 4th times 2 to the 3rd. And that would be 2 to the 4th power plus 3rd power, or 2 to the 7th power. So as long as the base numbers are the same and you're multiplying numbers with exponents, you just add the exponents. That's very simple. Okay, next we'll do rational exponents. Now rational, remember, has the word ratio in it, and it just means that there's a fraction. A rational expression means there's a denominator and a numerator. Let's use b to the 7th divided by b to the 3rd. Now, recall that an exponent in the denominator is the same as a negative exponent. So this could be rewritten as b to the 7th times b to the negative 3rd. Because b to the 3rd in the denominator is a negative exponent. So now, we do the same as before, we add them. So we have 7 plus a negative 3, or another way to write it is b to the 7th minus 3rd power equals b to the 4th power. Okay, and I just want to reiterate that the base number, the b numbers, the 2 in this case, the b, have to be the same to be able to use this rule. You cannot have b to the 3rd times c to the 4th. You cannot do anything with that. Punch some numbers into that. So you cannot add any exponents to solve this expression because the base numbers are not the same. And let's do another problem. Let's have 2 to the 3rd power over 2 to the negative 4th power. Now this is a little tricky because we have a negative exponent in the denominator. The rule still applies. That exponent changes signs when you bring it up. So this is the same as 2 to the 3rd times 2 to the negative 4th power, or 2 to the 3rd times 2 to the 4th power, positive 4th power. If we had this, that would be 2 to the 3rd minus 4th equals 2 to the negative 1, or 1/2. Okay, now let's look at this equation. b to the 4th over b to the 4th power. So just like last time, we will rewrite it as bringing up this exponent out of the denominator. Now, note that this means we've got b to 4 minus 4, or b to the 0 power. Take a look at this again. b to the 4th power over b to the 4th power, that's the same thing. That always equals 1, right? Any number over any number, the same number, equals 1. So b to the 0 power equals 1, always, regardless of what the base number is. So we could say 247 to the 0 power equals 1. Okay, now we'll look at the products of powers rule. I'm in page 23 in the text, and we've got this expression. Another way to write this is we break these out. So another way to write this is 2 to the 4th power times x to the 4th power. This is the same thing. See, we just broke each one out and put the 4 exponent on it. You will see this on page 24 in your text. All right, now let's look at this expression. So we want to break this out again. See, all I did was I just broke these out and applied the same exponent to them. Continuing on now, negative 2 to the 4th power. And you can work it out. You've got negative 2 times negative 2 times negative 2 times negative 2. These make a positive, so negative 2 times negative 2 is a positive 4, times a negative 2 is a negative 8, but negative 8 times negative 2 is a positive 16. So that's 16. Now this is a little different here. We have not seen this. This is not like the previous rule where we had y to the 2nd power times y to the 4th power. This is not the same thing. Instead, how we do this, we have y to the 2nd power, and this whole quantity is raised to the 4th power. So the way we solve this is we multiply. We multiply the exponents. This is called raising a product to a power rule. Okay, next I'm going to do example problem 6 out of the text, part A. And again, what we do is we apply this exponent to each the numerator and the denominator. We're going to bring the x up out of the denominator. And note that that's a negative 4, because that applies to the numerator, but because x came up from the denominator, it's a negative 4. Another way to write this, the exact same thing, is these are equal. And carrying it across this way, the exact same thing. This comes up. So we go ahead and work this out. Negative 3, you can punch this into your calculator. Negative 3 to the 4th power is 81. X to the negative 4th power is x to the 4th power on the bottom. And let's go ahead and do B of example 6. So this quantity is to the 3rd exponent. So again, we can rewrite this a couple of ways we can go. We can go x squared to the 3rd power over 4 to the 3rd power. Or we could write it x squared to the 3rd power times 4 to the negative 3rd. The book is keeping the denominator, so we won't do it this way. We'll keep it this way. I'm just going to rewrite it again. X2 to the 3rd over 4 to the 3rd. And again, we multiply these. We get x2 times 3. Put those in parentheses. And that should be x to the 6th over 4 times 4 is 16, times 4 is 64. Times 4 is 64. Okay, the final example I will do in this lesson is example 7 on page 25 of the text, and it's titled Simplifying Exponential Expressions. And basically what the text is doing is introducing more than one variable. So in this case, I'm looking at example 7, part A. All right, there's the problem. Now, and you noticed that we have two variables now instead of one. We have x and y. And again, we hit on this before, but you cannot do just taking this part of it down. Sometimes it's tempting to say x to the 4th power times y to the 5th power equals x, y to the 9th power. That is not true. You cannot do that. So what we have to do is we just keep x and y separate. All right, as before, we're going to break these out. So we know that all these are to the 3rd exponent. So we're going to start with this one. We're going to bring this one down. And here we have, again note, all of these have the exponent here. So as before, negative 3 to the 3rd power is a positive 9 times a negative 3 is a negative 27. So we have negative 27 times x to the powers of 4 times 3 times y to the powers 5 times 3. Rewrite it. That should be the answer.